Man, what am I supposed to do for my science project? I have no idea what to talk about for nuclear energy.
Sweetie, hi. You should probably go to bed. It's getting really late.
Alright, fine. Good night.
Ladies and gentlemen, I'm proud to announce we have a full understanding of nuclear energy and its full potential. We are proud to announce the universal application of fusion energy. Let's review the problems we faced in order to get here. Time to time travel. Oops, too far.
We are just now learning about the potential energy living inside the atom. You can reap the benefits from the fusion process. Fusion is a chain reaction that occurs when a neutron strikes a uranium atom, causing it to split into two smaller elements. When split occurs, there is a releasement of energy in the form of radiation. There are more somber sides to this new form of energy. It can be made into a weapon of mass destruction.
Good evening, America. I'm here with you tonight to share some very sad information. Yesterday, the U.S. dropped an atomic bomb on Hiroshima, Japan. Instantly, thousands were killed. We now see the potential power of nuclear weapons in the new era that we will come into. The next question is, what will happen with this destructive force? Where will it go and whose hands will it come into? I have one thing to say. That's good luck, America. Good night.
Nuclear reactors operate using the radiation released from a chain reaction. The element we use is uranium-235. This is the best isotope for creating nuclear energy. We use the radiation released to heat water in large boilers until it turns into steam. We then use the pressure from the steam to push a turbine, which then turns kinetic energy to electric energy. And that's how we turn deadly radiation to viable energy. Trust me, I'm a scientist.
So I just got out of environmental science class and I learned this thing about like the 3 Mile Island, and it was like in 1979, and a nuclear power plant in the USA experienced a cooling malfunction which caused part of the core to melt in this number 2 reactor. And like this caused TMI-2 reactor to be destroyed. So then some radioactive gas was released a couple of days after the accident, but not enough to cause damage to any, background local residents. Luckily, there were no injuries or adverse health effects from the 3 Mile Island accident. Pretty big deal.
Nuclear power plants are more efficient than ever before. New technology has made them safer and more reliable. Also, nuclear energy reduces greenhouse gas emissions. Building nuclear plants cost a lot of money, but in the end don't cost much to run. One reason the costs are low is that nuclear plants need only a small amount of uranium to produce a lot of energy. In fact, if the cost of uranium doubled, costs would only be increased by 7%. One truck of uranium produces as much energy as 1,000 trucks of coal.
Daniel, honey, it's time to wake up.
I had the weirdest dream. Wait, what the?
Daniel, honey, it's time to wake up.
I had the stupidest dream ever. But I know what I'm gonna do for my science project.
Good.
What? Let's do it.
What are you gonna do?
Alright. So, a nuclear structure. Alright. Nuclear structure is an atom that consists of an extremely small positively charged nucleus surrounded by a cloud of negatively charged electrons. Although typically the nucleus is less than 1/10,000th the size of the atom, the nucleus contains more than 99.9% of the mass of the atom. See how detrimental this is?
Yeah, man. Well, fission reactions can produce any combination of light nuclei so long as the number of protons and neutrons in the product sum up to those in the initial fissioning nucleus. As with fission, a great amount of energy can be released in fission because for heavy nuclei, the sum mass of the lighter product nuclei is less than the mass of fissioning nucleus. Wow, that's great.
And fusion. This reaction liberates the amount of energy more than... Nuclear structure is an atom that consists of an extremely small positively charged nucleus surrounded by a cloud of negatively charged electrons. Although typically the nucleus is less than 1/10,000th the size of the atom, the nucleus contains more than 99.9% of the mass of the atom. See how detrimental this is?
Yeah, man. Well, fission reactions can produce any combination of light nuclei so long as the number of protons and neutrons in the product sum up to those in the initial fissioning nucleus. As with fission, a great amount of energy can be released in fission because for heavy nuclei, the sum mass of the lighter product nuclei is less than the mass of fissioning nucleus. Wow, that's great.
And fusion. This reaction liberates the amount of energy more than 1,000,000 times greater than one gets from a typical chemical reaction. Such a large amount of energy is released in fusion reactions because when two light nuclei fuse, the sum of the masses of the product nuclei is less than the sum of the masses of the initial fusing nuclei. Once again, Einstein's equation E = mc squared explains that the mass that is lost is converted into energy carried away by the fusion products.
Okay, so basically what you're trying to say here is fusion is the next step in our hunt for energy. It is the solution to finding an environmentally friendly energy source. We brink of an environmental meltdown unless we reach the solution for nuclear fission. In doing so, we reach a new era of energy use on the planet and a new era of development and technology.
Do you think it's good?
Yeah, I think it's really good.
Great.
It's been a crazy dream.
Yeah, it was really stupid.